Greetings. Previously, we wondered if the 3n+1 procedure could do complex computations. If you know the game of life, it's worth some comparisons at this point. So there are stable patterns in life, like the block. The corresponding thing in 3n+1 might be the number 0. 0 is even, and so you cut it in half and then cut that in half. Now, life also has looping patterns. A simple one is the blinker, which goes like this. Its analog in 3n+1 is the 1-2-1 loop, which also blinks back and forth. Now, the blinker loops back on itself after just 2 iterations, but game of life engineers have actually found looping patterns for almost every loop length k. Strangely, they can't find a pattern that loops with k equals 19. But anyway, for 3n+1, we've only found one looping pattern, 1-2-1. Now, at this point, you might ask, what do life patterns have to do with start numbers for 3n+1? Well, here's an actual pattern shared among life engineers. And if you can encode a life pattern as a one-dimensional string of characters, then you can read that string as a giant integer. So life also begins with some start number, which it transforms into another number, etc. Now, the game of life also has looping patterns that move, like this glider. And an analog for 3n+1 might be a sequence like 457, 4570, 45700, and so on. Now, of course, we don't know if there's any start number that behaves like that. In fact, we don't know any start number that grows without bound for the 3n+1 problem. Not only that, life engineers have also constructed a glider gun which shoots out gliders. So a hypothetical glider gun for 3n+1 might be a number like 111111, and then it puts out a 457 to the left at some point after some number of rules, and another 457 and so on. So here the 1s are the gun and the 457s are the gliders. This sequence would also grow without bound. Finally, in life, glider guns can be used to create two-dimensional logic gates, and the logic gates can be arranged to form a general purpose computer. So you could convert any Python program into some initial life pattern, and life will do what that Python program does. If the program gets stuck in a loop, life will get stuck in a loop. If the program outputs 42, then you'll be able to read off 42 somewhere in the trace of the life sequence. Seems like 3n+1 can't do any of that. Now, maybe life engineers are just more adept than 3n+1 engineers. Or maybe they have more to work with. I mean, if you throw a bunch of random dots at life, you see all kinds of interesting patterns. That's why it's called life. And those patterns give you ideas if you're an engineer. But if you throw a random 200-digit number at 3n+1, all you see is a gradual, bumpy descent to 1. At least that's all I see. But maybe we're not looking hard enough or engineering hard enough. So in the next episode, we're going to pick a problem that 3n+1 might be able to solve. And it's a pretty mind-blowing problem.